Welcome, friends. Now, in today's lecture, we will discuss some of the topics on Unit 3. The Unit 3 consists of impact of free jets. This impact of free jets is a prelude as an introduction to turbines, centrifugal pumps, and reciprocating pumps. So, in this context, if you are thorough in impact of free jets, automatically you will be able to solve any problem in turbines or in centrifugal pumps. So your attention is required in this particular unit. So let us straight away go into this unit. So before going to the unit, into the regular topic, note that this hydraulics and hydraulic machinery subject having 5 units, the first 2 units devoted to hydraulics, the open channel flow, uniform critical flow, non-uniform flow, gradually varied flow, rapidly varied flow. That completes the hydraulics part. The unit 3 as an intro to hydraulic machines. So unit 3 is a bridge to unit 4 and unit 5. So unit 3, 4, 5 all together we call as hydraulic machines. So let us straight away go into the unit 3, impact of free jets. A simple unit, but definitely attention is required as it is interlinked with unit 4 and unit 5. So today's lecture is unit 3, impact of free jets. What is a jet? Any stream, a stream of fluid emerging from a nozzle is called a jet. For example, if you take a pipe, this is a pipeline. At the end of the pipeline, I have fixed a nozzle. Nozzle means whose cross sectional area is reduced. This is nozzle. So when water flows through it, the stream coming out of it, the water stream coming out of it, this is what we call it as jet. This jet possess high velocity because we have reduced the cross section of the pipe. So naturally, area of cross section is reduced. So the velocity should increase. So it has very high velocity. That is, the jet has high kinetic energy. Kinetic energy is nothing but half mv square. So this jet, now our topic I am coming, impact of this jet. So this jet means a jet with high velocity, possessing high kinetic energy, strikes, or you can call it as impinges a plate or a vein. Vein is nothing but a curved plate. What happens? What happens? When this jet strikes a plate or a vein, what happens? It exerts a force on the plate. It exerts a force on the plate or vein. This force is called hydrodynamic force. So again, first, what is a jet? Then this jet strikes a plate or vein. What happens? It exerts a force, and we call that force as hydrodynamic force. This hydrodynamic force, this hydrodynamic force is due to what? Is due to change in velocity. Change in velocity, or it is due to motion, due to change in motion. Therefore, it involves change in momentum. Bec- Therefore, to evaluate, very important, to evaluate the hydrodynamic force, we use impulse momentum equation. Impulse momentum equation. So finally, conclusion is what? The whole impact of free jets topic leads to what? The development of hydrodynamic force. And how to calculate this hydrodynamic force using impulse momentum equation. So what is this impulse momentum equation? Force exerted by the jet on the plate in any direction is equal to mass of fluid flowing per second into initial velocity in same direction minus final velocity in the same direction. So that means the direction is important. If you are taking the force in x direction, the mass flowing per second into the initial velocity in the x direction minus final velocity in the x direction. This you should remember. Similarly, the force in the y direction is equal to mass flowing per second into initial velocity in y direction minus final velocity in y direction. This you should remember. So having that into in your mind, let us see what are the cases that we will take it up in this particular chapter. What are the cases that we will take? Number one, force exerted by the jet on a stationary. You can remember this as fixed also, stationary plate or vane. So we are talking about in the first topic as stationary plate or vane. So how again here what are the cases? Case 1, when the plate is held normal to the jet. 2, when the plate is held in, inclined to the jet. Number 3, when the plate is curved. In the curve, we have three cases again. Jet striking at the center, it is symmetrical. Jet striking at one end, still plate is symmetrical. Jet striking at one end, plate is unsymmetrical. So these are the cases which we will study in the case of stationary plate or vane. So five cases all will come that we will do one after the other. Right. So case one, what is the case? Force exerted by a jet on a stationary flat plate held normally. So that means I will show you the figure also how it will be. So this is the plate. This plate is fixed, right? It's a fixed, stationary. Jet is striking normal to the plate. So this is the nozzle from where the jet is coming out, striking the plate and leaving parallel to the plate. The jet is coming out with a velocity v and leaves the plate with a velocity v. So this is the figure. Fixed plate, jet striking normal to the plate. Normal to the plate means this angle is 90 degrees, right? So that is it. So again, let D is the dia of jet. So A is equal to area of jet, right? Which can be calculated as pi d square by 4. First, now what the figure shows actually from the figure, jet strikes the plate which is held normally a fixed plate normally with a velocity v. That is the first thing. Next, after striking the plate, after striking the plate, the jet leaves tangential to the plate. So the moment it strikes the plate, it impinges the force. Next, we assume that the plate is smooth and there is the friction between jet and plate is negligible. Now, what is our problem? Now, what we will do, applying impulse momentum equation, applying impulse momentum equation, right? Now, impulse momentum equation, already we know it. Force is equal to mass of fluid flowing per second into initial velocity minus final velocity. So again, I will write for your convenience sake. Force exerted, force exerted by the jet on the plate in the direction of please see, incoming jet. Incoming jet is in which direction? X direction is equal to mass per second into initial velocity minus final velocity. Initial velocity and final velocity, which direction we should take? The same direction, direction of incoming jet It is nothing but x direction. The same we should take it here also. Now let us write one after the other. One, we have to determine this force. So the left hand side is unknown, which we have to do using the known quantities on the right hand side. So first, what is mass per second? Mass per second is what? Mass is equal, mass by volume is equal to density. So mass is equal to rho into volume. So mass per second is equal to rho into volume per second. This volume per second is nothing but we will write it as discharge rho q, and q is equal to, according to continuity equation, you know it. So mass per second is rho AV. This is first. Then what is initial velocity? Initial velocity in which direction? In the direction of incoming jet. That is V. What is final velocity? Final velocity here is important because the jet, after striking it, it is not in the x direction, it leaves parallel to the plate. So what is the velocity in the direction of incoming jet? In the direction of x direction, what is the final velocity? That is equal to 0, because the jet is not anymore in x direction, it is leaving tangentially. So the jet, already in the figure you see it. So in the x direction, what will be the velocity, final velocity? No final velocity, so it is 0. So now put it. So therefore F is equal to rho AV into initial velocity minus final velocity. It is nothing but rho AV square. Very simple. F is equal to rho AV square. For you, rho is mass density, and for water, rho is equal to 1000 kg per meter cube. This is for water. Generally, we deal with only water. Then what is A for you? Basically, A is nothing but area of jet. So area of jet, how we will get it? It is nothing but pi d square by 4, where d is the diameter of jet. V is nothing but the initial velocity. So if we know these things, we can find out this. F is equal to rho A V square. Now the plate is held how? It is held normally. Now in this case 2, what I will do is I will change it to inclined position. Case 2. Force exerted by the jet on a stationary inclined plate. How the things will like it. Just I will show you how it looks like. Suppose, for example, inclined. So I am taking the plate like this. Okay. This is the plate. Again, fixed means you should show it. Now this is the direction of jet. Just notify it. Just understanding. Right. Now the jet is coming from somewhere here. Okay. Now how the jet actually strikes. The jet coming here, it leaves like this, right? The jet comes out here with a velocity v, again like last, and it leaves like this with a velocity v. This is the thing, and this angle is not 90, it is some theta. This is our problem. So how this type of problem is solved? When it is kept in an inclined plate is kept, which is making an angle theta with the horizontal jet. Again, like last time, you can calculate what is, because what are the items that we need to calculate? Number one is mass, number two is initial velocity, number two is final velocity. If these three are known, then we can calculate the force. But here my problem is, previously the entire force is only in the x direction. But now in this problem, if I see it, it is not like this. Plate is inclined. The moment the plate is inclined, naturally the forces in x and y directions both will come into picture. So how to calculate those forces is my first thing. So first, if I resolve that, then calculation will be very, very simple. So what I do for that is, first thing is I draw basically a normal to this plate. So what is this? This is normal. So what I do is I calculate what is the normal force. Once I calculate the normal force, that means this is how the normal force is. So once I calculate this normal force, naturally, if you see it, this normal means what will be the angle actually? If I see, this is how the plate is, right? And this is how the jet is basically the striking. So this angle is theta. This angle is 90 minus theta. So this angle is 90 degrees, normal actually. So what I do, once I calculate it, this is, I calculate both what is fx and what is fy. If you see here, if Fn is the normal force, and how to calculate the normal force, I know, because of my previous case is only that jet striking normally. So assuming that the jet is striking normally, I calculate the normal force. Once I calculate the normal force, I calculate what is Fx. You can from here itself tell what is Fx from this actually. For example, if you see it, what is Fx? Fx is equal to basically Fn sin theta. And what is Fy is equal to Fn cos theta. So this is the thing. So if I find out Fx, Fn, then I can find out this. So this is the way which I will go forward. So again, before going forward, first let me tell you, then what is the thing actually? D is the diameter of jet. D is dia of jet. So A is the area of jet. Area of jet, how we will calculate? A is equal to pi by 4 into d square. That also you know it. So therefore, what is the mass of fluid striking the plate? Striking the plate, it is equal to rho into Q. So it is equal to rho AV. So this is number one over. Once this is over, now again assumptions are same. Plate is smooth, so naturally the friction between the jet and the plate is negligible. After striking the plate, the jet leaves tangentially. Then now next my question is, straight away I go in applying impulse momentum equation. Applying impulse momentum equation, applying impulse momentum equation, force exerted, force exerted, basically normal to the plate, is equal to mass per second into initial velocity in normal direction minus final velocity in normal direction, because direction is very, very important. So if I take it, this is Fn is equal to mass per second is rho a v. Fine. What is the initial velocity in the normal direction? So normally this is the direction. In this direction it is v, but I want actually in this direction. So it is v cos 90 minus theta, v sin theta, v sin theta. Final velocity is after striking it, naturally it is leaving tangentially. So in the normal direction, there is no velocity. So now this is final velocity in the normal direction. The jet after striking the plate leaving tangentially. So there is no question of any velocity component in the normal direction. So this is Fn is equal to rho a v into v sin theta minus 0, so rho a v square sine theta. So this is what we got it. Once that you got it, I mentioned already fx is equal to fn sine theta, which is equal to rho a v square sine theta into sine theta. So rho a v square sine square theta. Fy is equal to fn cos theta. It is equal to rho a v square sine theta into cos theta. So this completes fx, fy. So this completes the second definition. And if you want resultant force, F is equal to square root of fx square plus fy square. So this completes to me two cases. So with this, I will stop the first lecture, and in the second lecture, I will complete the other three parts also, so that we will complete all the stationary plate. Okay, we have completed the calculation of hydrodynamic force for two cases. That too, in case of jet striking a stationary plate. Plate is held normally, plate is held inclined. For these two cases, how to calculate the hydrodynamic force. That we have done it. And in the next second lecture, we will take the curved plate or vane. Right? Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.